Hey number crunchers, let's look at multiple representations of functions. We can represent functions in different ways, like a description, a table, an equation, and a graph. Let's try an example together of how we can change a verbal description, which is the context in words, into a table or a representation of data in rows and columns. We can change it into an algebraic form, a representation using numbers or operations, variables, and an equal sign. And we can also graph it. This is a representation with data points on a coordinate plane. So our example here, our description is, it was raining all day. The rain gauge tracked the rainfall as 0.2 of an inch per hour from 8 a.m. to 8 p.m. So if I want to make a table, I see that I'm going to count up by whole units of hours. So in my first hour, it was 0.2. I can write this as a decimal like this. The rainfall was 0.2. By the second hour, it was 0.4, and 0.6, 0.8, 0.10, which is just 1 inch, and 1.2 inches by the 6th hour. So X represents the hours or the independent variable, and Y represents the rainfall or the dependent variable. Now, for every time I'm increasing X by 1, I am increasing Y by 0.2. So I can write it as this equation, Y equals 0.2 times X. And finally, I can write this in graphing form. So we're going to put along the x-axis my hours, so time, and I'm marking that by hours. So I'm just going to label this 1, 2, 3, 4, 5, 6, 7, like what we put in our table. And along our y-axis, I'll put rainfall. And I'll use the same numbers that I have in the table to equally spread out my values. So in the first hour, we had 0.2, second hour 0.4, third hour 0.6, 0.8, and I keep on going. Now, this isn't a discrete graph. I can have parts of an hour. So if the rain was falling at a steady rate, I would have a steady line like this. Go ahead and try the rest of the practice below and check it with your teacher to see how you did.